Hi class, I had a student email me about a homework question this week in the Chapter 13 homework. This is number 5. It's about resting pulse rates. And this one, we had one last week like it that used the ANOVA test, I believe. And then this week we're going to use the sign test. I'm asked to use a sign test. So I'm going to open the data. I have a pulse before, a pulse after, and we see that most of the time the pulse did go up. Sometimes it went down. I'm going to open that in StatCrunch, and I'm going to go ahead and change these and delete this row so that I just have the data in there. Notice that my null hypothesis is that it remains the same, and the alternative hypothesis is that it goes up, and I get that from this sentence. See whether the pulse rate went up significantly or not. I am asked to do a sign test on this. So I'm going to go to non-parametric sign test. Notice I have 2 columns here, and the problem is that I need to have 1 column for the sign test. It just looks at the sign of the number. So I have 2 choices I can do. First, I'm going to cancel this. I can make a 3rd column that is before. If I think it goes up, after will be positive. So let's do before minus after. And in order to do that, I'm going to have to create a expression. So I'm going to compute an expression. I'm going to click build. I want to take before. I want to subtract after from it. So I clicked BF to put before up there, clicked add column. Click the minus sign, click the after column, hit add column, and then I hit OK, compute, and it did the subtraction for me, before minus after. I'm now going to go back into StatCrunch, go to non-parametric sign test, and I have that 1 column, before minus after. If I think it goes up, then I think this after is larger than the before. So this number, when I subtract, should be less than 0. I have to just logically figure that out. Sometimes when I see the word goes up, I want to say greater than, but goes up means after is higher, and so when I subtract a lower number minus a higher number, I'm going to get the less than 0. Then I hit compute, and note that I get a p-value of 0.5. Oh, ask me what the test statistic is first. My test statistic is whatever is below, which is 5. So I'm going to put 5. And the p-value was 0.5. And so 0.5 is certainly larger than 0.05, so I will not reject the null hypothesis. If I don't reject the null hypothesis, then it looks like it remains the same and did not go up significantly. Let me show you that some of the questions this week you don't have the before and after. This test will work exactly the same and get you the same values even if you don't have the specific data, as long as I know whether this is positive or negative. So for instance, there's one this week with brides and grooms and ages, and as long as you know it's negative, I can just put any negative number in there, any positive number in there. Notice that what's the same is the signs are the same. So I have negative 14, negative 1, 20, 1, 3, 1, 5, 1. I am putting a negative wherever I have a negative number and a positive wherever I have a positive number. And now watch what happens when I run the same test on this new data that's not even the numbers from this problem, but just the same signs as this problem. I get the same S value. Oops. Oh, I forgot to change the sign. I need to change that to less than, so I'm running the same test, and I get the same p-value. Hope that helps. Have a good week.